So today we're talking about how to graph a line using intercepts. Okay, intercepts are just where your line is crossing the x and the y axis. All you need to graph a point are all you need to graph a line are 2 points. So if I have these 2 points, I can draw a line through it and be done. And the x and the y intercept are generally really easy points to find because for the y-intercept, x is always going to be 0, right? Every single time, it doesn't matter where it's going to lie on this y-axis, the x is always going to be 0. It could be 0, 1, 0, -3, 0, 9.5, but the x value is always 0 for the y-intercept, and for the x-intercept, the y value is always 0, right? Because you're going to be somewhere along this x-axis, so it could be -2, 0, 2, 0, what is that? 4, 0, okay? As long as the y is 0, that's going to be your x-intercept. So when we are finding the x and the y-intercept, what you have to do is exactly what we've been doing before with filling in the value that you know, okay? And in this case, it's either going to be the x is 0, and then we're going to do it where the y is 0. So let's find the x-intercept first, right? So if you go back up here, when we find the x-intercept, the y is always 0. So if I put a 0 in here for y, 2x plus 7 times 0 is 28, right? What's going to happen to that 7 times 0? It's just 0. I don't need it. So I get 2x is 28, so x is 14. So this is going to cross the x-axis at 14, right? If I were to go up here and draw it, it would be way over here at 14. So now when I find my y-intercept, the x is 0. So 2 times 0 is 0, plus 7y is 28. Well, 2 times 0 is 0, so I just end up with 7y is 28. So y would be 28 divided by 7 is 4. So if we were to graph it, we would come all the way over to 14 and up to 4, and we would connect those 2 points. Okay, we're going to skip a little bit. I'm going to come over here to number 3. Okay, so when I'm finding the x-axis or x-intercept, y is 0. It's almost like it just goes away, right? Because 2 times 0 is 0. So what I'm left with is just 4x equals 10. Now we're going to solve it like we've done a bazillion times. We're going to divide both sides by 4, and I'm left with x equals 10 over 4, which is the same as 5 over 2, which is 2.5. Either one of those is totally fine. Okay, and now when it's time to find the y-intercept, x is 0. So if I put a 0 in here for x, 4 times 0 is 0, and again, it's almost like it just disappears, and I'm left with the equation -2y equals 10. Okay, and y'all understand it's not actually disappearing, right? It's just that when we plug a 0 in, it goes away. So now we're going to divide both sides by -2, and that leaves me with y equals, you don't have to write y equals, I just did, -5. So my y-intercept would be down there at -5. So if I were to put it on a graph, I would have 2.5 somewhere right here, -5, and it would go like that. So let's talk about what happens when it's not written in standard form. Okay, if y'all will remember from yesterday, standard form is like how this one looks and this one. Standard form is ax plus by equals c. This right here is in slope-intercept form, which is y equals mx plus b. So the first thing that we're going to have to do is we need to rewrite this in standard form. And actually, before we can even rewrite it in standard form, we need to fix it because it should be y equals 1/2 x plus 3, not 1 over 2x. Okay, 1/2 x. So if I want my x and my y on the same side, right, pretend it wasn't a fraction. If it was just 2x, okay, think about solving equations. How would you get rid of that 2x? You would subtract it. We're going to do the same thing, right? Sometimes people kind of freak out because it has a fraction attached to it. It's the same process. We are going to subtract 1/2 x from over here, And if I do that on the left, I have to do it on the right. So now I end up with negative 1/2 x plus y equals 3. Okay, so let me show that to you one more time. Okay, so we had y equals, I can't tell if I can see that. There we go. Y equals 1/2 x plus 3. So if I don't want this 1/2 x over here, I'm going to subtract it, because half an x minus half of an x is no x's, right? If you have half an x and I take it away, now it's gone. So over here, I have negative 1/2 x, right? Or minus 1/2 x and a y. Can I add those together? No, they're not like terms. So I have negative 1/2 x plus a y, and over here on the right, I have equals 3. So now that it is in standard form, ax plus by equals c, I'm going to start by finding my x-intercept. So that's where y equals 0. So I have negative 1/2 x equals 3. So forget about the negative, right? Half of x is 3. What's all of x? 6. And it's a negative. Okay, if you really like the process, right, negative 1/2 x equals 3, you would multiply both sides by the reciprocal. Cancel, cancel, x equals 6 over negative 1, which is negative 6, right? You can also use number sense. If half of x is 3, all of x is 6. And then the y is crazy easy. If I put a 0 in here for x, what's left? Y equals 3. Okay, so why do we even care, right? It seems like a lot of work to find these 2 points. Well, here's why. Okay, let's look at number 10. If I'm trying to find the x-intercept, that means y is 0. So I have 2x equals negative 6. X is negative 3. So I can put a dot right there. And then when I go to find my y-intercept, x is 0. So 3y is negative 6. So y is negative 2. Those are my 2 intercepts. I can connect them with the line, and I'm done. Okay, on this next one, it's not written, right, in standard form. So I'm going to subtract 2 x's from both sides because I want these to cancel. So negative 2x plus y equals 10. So now when I go to find the x-intercept, negative 2x is 10, which means x is negative 5, which would be right here. And when I go to find my y-intercept, x is 0, so y is 10. Right there, line, and I'm done. Okay, and this last one, again, it's not in standard form. I'm going to subtract 4 x's from both sides. So negative 4x plus y equals negative 8. And then when I go to find my x-intercept, negative 4x is negative 8. So I divide both sides by negative 4 to get x is 2. And then here, when I put a 0 in for x, I just get y is negative 8. So y is negative 8, x was positive 2, and this is how we connect it. So let's apply this to a real life situation. It says, you are helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6. So I'm going to call the small tables X, and I'm going to call the large tables Y. Okay, small is X, large is Y. So if I was going to write this as an equation, right, there's 4 people at every small table plus 6 people at every large table, and all together we want to have 180 people. So now we're going to find the intercepts of this equation. Okay, so intercepts, remember, it's just where one value is 0. So what if I rented no large tables, only small? That means 4x is 180. I would divide both sides by 4 to get x is 45. And then, well, what if I only bought large tables? So that's 6y is 180, so y is 30. So now we're gonna have to graph this equation. I'm gonna count by fives, 5, 10, 15, 20, 25, 30, 35, 40, 45, and then going up the side, I'm gonna count by fives, 5, 10, 15, 20, 25, 30. Okay, so if I were to only buy small tables, I would have to buy 45 of them. It's essentially my small table intercept. Okay, what if I only rented large tables? I'm gonna have to rent 30 of them, right? When I rent 0 small, I have to rent 30 large. When I rent 0 large, I have to rent 45 small. So now I'm gonna connect these. Whoops. And look, this time I actually have a ruler. If I can get it off my desk. Okay, so I'm gonna connect these 2 points. Okay, and I'm gonna explain why it's important to be a little bit more accurate maybe than we've been in the past. Okay, that would be our line. And it's more important now because we are gonna be looking for possible coordinate pairs, so we have to be a little bit more exact. Okay, so let's look for some coordinate pairs. Okay, it says give 4 possibilities for the number of tables you can rent. Okay, well the first one, it's super obvious. It's 45 small, 0 large. Right, then the next one is 0 small, 30 large. Okay, so let's look for another one. Right here, do y'all see how this is where this and this intersect? So that's 15 small and 5, 10, 15, 20 large. And then let me grab one more color. Okay, did you see another combination? Do you see it on your graph? Right here. Okay, and this is at 30 small, 5, 10, 15, 20, 25, 30, and 10 large. Okay, and we don't have to, but I just want to show you real quick that, remember, we're trying to seat 180 people. So 30 times 4 is 120, 10 times 6 is 60, 120 and 60 is 180. Okay, 15 times 4 is 60, 20 times 6 is 120, 60 and 120 is 180, right? We're trying to seat 180 people. So then down here, it says, what if the small tables cost $9 to rent and the large tables cost $14? Of the 4 possible combinations of tables given, which rental is the least expensive? Okay, so 45 of the small tables that are $9, 45 times 9 is going to be $405. Okay, what if we rented only large tables? Well, that's 30 of them, and they're $14. So 30 times 14 is $420. Well, what if I did 15 small? So that's 15 times 9, which is 135. And then 20 large, and that's 20 times 14, which is 280. So that's 415 for that option. And then this last one, 30 times 9 is 270. And 10 times 14 is 140. And when I put those together, it's 410. So the least expensive option is to rent 45 small tables.